Okay, now we'll move on to Table 3. I have added the information, or I have kept the information from Table 2 because we will need it, or you will need it to calculate the numbers in Table 3. And I've also just taken the mercury as an example, and you will need the size, the model size of the Earth. Okay, it's a different model now, but we're still going to make use of the information from Table 2. So first of all, we need to figure out the model size for each of the planets. I'm going to give you the Mercury example. Okay, I don't know what the model size is for Mercury, but I know that my Earth, the model size for it is 2.426 centimeters. Now be careful, because in this table you are dealing with centimeters, whereas from Table 2 the size is in millimeters. So when you use those values to calculate the distance from the sun, you're going to have to convert either centimeters to millimeters or millimeters to centimeters. So how do we go about doing this? Let's start with the model size. So here's my Mercury. Once again, it's a simple ratio. The model size for Mercury over, which I don't know, and I will say x. So x over the model size, so x centimeters, over the model size for the Earth, which I know that it's 2.426 centimeters, should be equal to the model size. I took the bowling ball example. The model size for Mercury, which is 1 millimeter, divided by the model size for Earth under bowling ball, which is 2 millimeters. Okay? Cross multiply and set the products equal to each other. So I have 2.426 centimeters times 1 millimeter should be equal to this product, 2 millimeters times x. To isolate x, I divide by 2 both sides. My millimeters here cancel. This here cancels completely. And this number, x, should be 1.21 centimeters. So I go ahead and fill that in the table, 1.21. Remember, this is in centimeters. Okay, so how do I then go about figuring out the distances? This is how we're going to be doing the model sizes, comparing model sizes of Earth to each planet, and then model sizes here are going to be x's divided by 2.426, just like this here. But how do we go about doing the distance then from the sun, now that we figured out the model size? Okay, once again, we make use of Table 2. Let me just erase this real quick. Then I'll show you how to fill out the distances. They're, once again, simple ratios. So that's why I say once you learn how to set up the ratios, you can do all of these calculations. They're not that difficult. Okay. Now, I know that for this model size, and I'll stick with the bowling ball, I know that for Mercury, the model size for bowling ball divided by the distance from the sun to the for the bowling ball, so before I do that, because this is in millimeters, I'm going to have to convert it to centimeters, which is divided by 10. So it will be 0.1 centimeters divided by 9.7 meters. This ratio for the bowling ball for Mercury, so model size but converted to centimeters, over the distance from the sun for the bowling ball for Mercury should be the same as the model size as 1.21, which we just calculated, centimeters, divided by the distance from the sun, which I don't know, so I'm going to call y. This is what I need to find out. Cross multiply and make the products equal to each other. So I have 9.7 meters times 1.21 centimeters is equal to 0.1 centimeters times y. Divide both sides by 0.1 centimeters to isolate y. That cancels. The centimeters cancel here, leaving me in meters. Y is equal to 118.44 meters. Now you can see why I had to convert that model size from bowling ball from millimeters to centimeters here, because this unit is in centimeter, and if I had this in millimeters, the units would not end up canceling. So this is how you calculate both the model size and the distance from the sun for table 3.